let's hear about what the online group discussing site selection came up with during this last discussion period.
Hi, I'm Jo Neild, and I was taking notes on our session. So I guess we focused only on kind of a lander rather than a rover. And we spoke about two different options. So deployment, depending on what kind of science questions we ultimately ended up with and how much money. So either a large network of simple sensors that maybe we deployed in 30 different locations. So that would enable some kind of larger scale questions to be answered. So something like having a 3D sonic anemometer on 30 kind of pins that fall into the ground. And you could get then flow characteristics around a crater. So you might have some upwind, some on the edge of the crater and some inside the crater. Or to answer questions about flow and transport within dune fields, you might have some upwind and downwind of a dune field. But then the second kind of option might be for really getting into the nitty-gritty of the transport surface wind relationships. So then we might just want one lander that was fully outfitted with all the sensors that could kind of characterize those small scale measurements. And so for that, we really need to be really specific about where we land. So there we want to kind of avoid any obstructions on the flow, think about needing an upwind source, understand the wind and transport directionality. So thinking about whether we want a site with a unidirectional wind so we know which way to face our instruments, or if we can move our instruments around, then maybe a multimodal wind direction will give us more opportunities depending on which way we end up with where the sand source is going to come from. Or maybe you want to go for a hybrid of kind of just having 3 landers rather than 30 or 1. And then we also spoke about the choice of location probably depends whether we can get a dedicated mission or whether we have to hop on to someone else's. So if we can get a specific mission, then we'd prioritize a dune site, ideally focusing on somewhere where there's evidence of ripples and active transport. And then we can really be precise about where we deploy. But if we're joining on another mission, then we probably want to focus more on a kind of dust type question where we don't have to be so precise about where we land. And then the other thing we mentioned was about kind of when we land, how the instruments are arranged. So trying to get a site where we're not going to hit a rock and be lopsided, or thinking about how we can kind of loop into the next kind of topics about how we then try and level our instruments, particularly if we were going to have sonic anemometers, for example, and how we try and get the instruments closer to the surface. So if we chose somewhere that was flat and didn't have obstacles and not many rocks and wasn't subject to deep pits of sand, then it might be simpler for the people in the next session topic. Did I miss anything?
I might add one thing, and that is some of our agenda might be best served by sitting in one spot for a long time, watching the environment and perhaps the changes in it. And there's some studies, like maybe dust devil studies, might be better served tagging along on a rover where you've got a number of different sites being visited within the same general area. And that might be a way to compensate for a lack of a network. But if it were an Aeolian targeting mission, then whatever the goal is of that gets priority in choosing the site. So if it's looking at sand dune migration, obviously we'd go to such a place. So hopefully we get a Aeolian priority mission, and if not, there's pluses and minuses to tagging along on other missions.
Great. We have a moment or two here. Does anybody else have any questions or comments to add to this so far?
We're kind of worried about having a single point source of fancy instruments that lands and stays where it is, but have it land in a bad spot. So one of the advantages of a network of perhaps simple instruments is that some of them will land poorly, some of them will be great. They'll be in a variety of different environments, and they'll all simultaneously be in contact with sort of keeping track of context. And I know this goes into the second group's discussion, but if we do land a fancy package and something's tilted or it's a little off cue, wouldn't it be lovely if there was a way for the instruments to be righted or pushed a little further off to a side or something to try to address that inappropriate or unfortunate placement?
Right. And another way to put that is a single lander mission will probably put more requirements on the engineering to mitigate risks like that you might accept in a network. And what are those trade-offs? Very cool. All right. So then, yes, Serena has something here in the room.
Thank you. I got to listen into some of this conversation and it was very interesting. I want to highlight the question about the possible tilt. That was something we had a long discussion on as I was trying to clarify how much of it is we obviously need to know where the instrument is and how it's oriented and how it's tilted in order to properly interpret the measurements. So for instance, right, you have your 3D sonic anemometer. If it's tilted, it's measuring things in 3 axes, but you need to know where those axes are, not only in space, but also their orientation. Versus which instruments can't be tilted, because if they are tilted, they can't take measurements at all, right? So one of them, as long as you know where you are, you can calibrate it out or correct for it or something. But the other one is if you're actually tilted, you lose your measurements or it's significantly degraded. And the reason I was pushing on that is if I ask every time I ask the engineers, right, for one more motion, there's a chance that they come back and say, okay, one more instrument off, right? Because we have to add in a mechanism. So anyway, I thought that was a really interesting point to think about. I thought about position and I thought about orientation, but I hadn't yet considered the third of tilt. But that is an important consideration for these types of measurements. So, yeah. Yeah.
This is Brian in the room. Yeah, this conversation came up a little bit in the field yesterday. And I was just curious to know how much of the tilt could be processed out of the data stream. Is there a way to do that? So I kind of posed this a little bit in the field yesterday, and I think folks had some good responses. So I'd be curious to know if people in the virtual world had any thoughts about this too. Can we process out a tilt?
I think we decided it depended on the instrument. So for example, 3D sonic anemometer, as long as you can work out what the orientation is, you can try and correct for, as long as there's not something obstructing in the way. So it also depends on, I guess, the shape and how the instrument is hung from the lander or the rover. But then we were more concerned about things that measured only in 2 dimensions. So, one dimension, things that really needed to be pointing towards the flow or parallel to the flow. Those are going to be harder to correct for.
Well, I think another example, it would be if you had an all sky radiometer where in order to do the experiment, you need to see the sky and you're tilted so much that you're mostly seeing ground or a large fraction of it, that experiment might not be doable anymore. So, and no amount of computational adjustment afterwards will really get you back the sensitivity you designed for. So,
or like Joe is saying, a flow through tube or something that
yeah,
needs to be whatever it needs to be. There might need to be, after landing, at least once, that instrument might need to be manually adjusted in some way.
Any more thoughts and comments? So let's go ahead and then do the in-person group for the same topic, which who did site selection? Who wants to talk about site selection from here? Who are you all pointing to? Come on up, give a talk. One of you. Huh? Oh, could be more. Yeah, you could go up too. Help
Yeah,
her.
please feel free to contribute. All right, so we briefly
So
discussed.
please tell us who you are, real quick.
Oh, sorry, Lauren Berger, Texas A&M. So we briefly discussed for the moon that the best place to go for ground atmosphere interactions was near the terminator line. Yep. Because it shifts, but it lasts Earth days, and then the potential broad swath of latitude. And we kind of thought not the equator. And then for Mars, there was a discussion about trying to get dust and saltation. And a lot of discussion about returning to previous landing sites. So we all kind of agreed that Meridiani would be a great idea. There was some talk about InSight, and then also trying to go to some dust corridors where you would have a higher frequency or a higher possibility of dust devils passing by. And then there was also the discussion of Titan and the Dragonfly mission and the ability to go to different places, because part of the concerns about landing in different places is you might land right behind a boulder. And now all of a sudden, kind of like the group online mentioned, it's now all of your readings are off. So the ability to slightly adjust where you're located or just having multiple instruments was also taken into consideration.
Great.
Just to
So we
cl-
have some questions in the room here, and then we'll take some from the online.
Okay, this is just to add to what Lauren was
Okay.
saying, that the dust corridors were not for dust devils, those were for dust storms. So there are some areas where the regional dust storms preferentially form and come through on a regular basis. So if you want to go just to study the dust storms, that's a great place to go.
Did you discuss landing on a dune field?
Yeah, we talked about maybe landing in a crater so there are several craters that have dune fields in them, where on one side of the dune field, the dunes will be pointing towards the center of the crater. And on the other side of the dune field, the dunes will be on the other side of the crater, but also pointing towards the center of the crater. And what's going on? Why do they do that? Because we don't see this on Earth. So if you were to land right in the middle, or maybe send multiple landers on, upwind sides and in the center. So yeah. I think the problem with landing in the dune field itself is the topography might affect some of the atmospheric measurements, but if that's what you want, then maybe that's great. So multiple missions, I think, came up. So
Do we have any questions from people online on this, on what was mentioned by Lauren?
We also mentioned targeting a dune field, and that might be a good time to request sort of a hybrid mission. Not exactly a widespread multi-node network, but perhaps 2 or 3 modestly equipped probes, so that perhaps one can be placed upwind of the dune field, another downwind, and sort of halfway between the complexity of a single point source of everything you can fit on that lander versus a ton of simple crude ones. But that would give a more focused look at a dune field and possibly monitor its budget, transport budget better.
Great. Anything else from anybody?
Might just tag on to what Steve was saying, because I was in that group. We also talked about, you have to make a determination, I guess, in terms of whether you're going to select a geomorphically simple site or a complicated one. And it might make a lot more sense for what Steve was describing there, to start with a sort of as simple a scenario as possible. Of you've got a unidirectional wind regime, single direction of sand transport. You don't have a combination of sand and dust transport going on. things like that.
Great. We can keep coming back to this, but let's go on to spacecraft accommodation. And we'll go with the online group first. And I believe I was told that Don Banfield was volunteered again to do this.
Yeah, I was. Actually, Claire took the notes, and she can't be here right now. So I'm going to just kind of report out on the notes that she took. So bear with me. She writes more than I do, so it's going to take me a little while to take her paragraphs and make them into a sentence. Part of the discussion that we had was about something I think the other groups have already mentioned, the question of whether you want a whole bunch of simple small landers that are maybe not terribly well equipped or don't have great instrument accommodation versus one or a few more sophisticated landers. And I think exactly where that breaks down into between, what's the best science approach, either one really highly sophisticated lander, a few medium landers, or 20 or more very simple landers. That's something that we didn't really come to a conclusion on, but we identified it as a very important question. The other aspect of that is that for maybe the surface interaction processes that we're talking about a lot in this meeting, you might either want a small network or a very well-equipped single lander. Whereas if you're interested in more global scale meteorology processes, you may want something that's more many simple landers distributed. We griped a fair amount about wind sensor accommodations on past missions and how difficult it is in general to do it well within the constraints of a spacecraft. Yeah, I guess I don't know what more to say other than that we griped a lot about that. I think one takeaway from that was that you kind of need a mission that is scientifically focused on surface atmosphere interaction for the accommodation to be listened to, the environmental measurement accommodation to be listened to properly. Let's see, we talked a little bit about a Venus mission that could last for like 60 days and is relatively inexpensive and uses just strain gauges to measure winds. But that too also has accommodation challenges in that the dynamic pressure from the wind itself can start causing flutter in the instrument. And so that's a challenge, apparently. I guess the final thing I'm going to mention that Claire said is that we might consider how important it is to pay some graphic artists to do some visualization of what we actually feel is important when we get to the point of putting together a proposal or even advocating in like NASA forums or MEPAG, because it's very difficult for people that aren't specialists in this field to visualize what it actually takes to properly accommodate an instrument and get good measurements from it. So that was one of Claire's suggestions. I guess that's about it. Questions? Or did I miss anything for others in the discussion? Perfect. I made no mistakes. Awesome. I'm being sarcastic.
All right, well then, since there's no immediate questions, we're going to go with the in-person group, and Abhilash from the University of Arkansas will give us a quick summary.
Hi, my name is Abhilash. I'm from University of Arkansas. So Eddie took the notes, but okay, yeah. So Eddie took the notes, but he was not here, so I just have a quick notes of it. So what we discussed was so different parameters, like where the instrument needs to be placed. So in order to maximize the measurements, so and different things. So we need to have surface, near surface, and subsurface measurements. So if we can have sort of a robotic arm, so which can drill into the surface and get as many parameters as possible. And also there was talks about to measure saltation processes, and also through different heights. So there was a discussion about having helicopter versus mast, like if helicopters were can be used maybe potentially in the future. But then there was also a talk, the rotary blades would distort the winds around, and that would not be a feasible solution. And there was also talks about how if it is possible to use a balloon like fitted with different instruments on a tether, but that is also like a sort of a questionable and debatable one. So anything to add, Tim or Alejandro?
No, I think that covered it. We talked about a lot of more high risk ideas. So does anybody in person or online have any questions?
I do. To the question of if we land and the spacecraft is sitting on a rock or behind a boulder or something, I would hope that we try to pressure the engineers to have some method of trying to recover from that, either to tilt the sensor back up to whatever its orientation needs to be, or perhaps an arm to place it a ways away, or some sort of clever trick to deal with the fact that you might be stuck on the surface in a bad deployment. So that's the only point I wanted to see if that resounded with other people.
Hey, Steve, this is Don. My comment is that, sure, I agree with that. But I think the reality of trying to put together these super low mass missions and accounting for the mass and risk that any deployable or mechanism accounts for means that you probably aren't going to be able to do that. So it feels to me like what you need to do is think about how to design your mission so it's robust even in that situation.
So we have a question for a comment from Tim here.
Yeah, and I would add that as part of the site selection, choose some place that's got fewer rocks, and the rocks that are there are smaller. I mean, that's sounds like a no-brainer, but picking the right landing site to mitigate these risks probably is your cheapest option.
So I just saw that James King put up a question: what accommodations exist for placing sensors away from the lander rover that is not a drone? The influence of the unit on flow is important. And yeah, some of us have been talking about that, and both at the Dunes meeting and here, I've been talking about my wacky idea of having a robot that drives around and sticks poles in the ground and drives away, so that you can just have a standalone mast. But I think all those things, I'd like to hear from everybody else, but my personal opinion is I'm saying these things in tongue in cheek a little bit because I think the technology for that and more importantly, the budget for that is far out for us. But it would be nice to have a way of setting up the instrumentation separate from the main body of the spacecraft and just, relay the data back, but have it less obstructions to flow and to observations. Thoughts?
Someone better informed on this topic should speak up. This is Brian in the room. But I have the impression that for landed instruments, that oftentimes they're trying to model out the effects of the lander body and other hardware on the measured flows. Maybe that modeling out is just a terrible thing and never works out very well, but is that not something that we could address in that way?
So I will say that at least for In-Situ, we talked about doing that, but the budget didn't support doing the really detailed CFD analysis that it would take to, given the measurements at the location of the wind sensor, infer what the winds are at infinity, let's say. And that's even not considering the issue of stability changing over the time of day. So if you just consider neutral stability, nobody's done the CFD. It takes a lot of money and time to do that. And then the extra dimension of diurnal variation in atmospheric stability just makes it essentially an intractable problem, I think.
Hi, this is Jack from DRI. I think one of the maybe things that makes it a little bit easier for Mars, if you following up on your idea, I want to deploy a small mast.
Right.
The great thing about that is the drag on those things is going to be much lower than they are on Earth. So you be able to keep them more upright with less engineering, shall we say. And if you could actually figure how to do a weeble wobbles, but it won't fall down. So you can probably, I think that would benefit the engineering of something like that. You don't have to worry about guy wires and all that as you do on Earth. So
Yeah, I was just thinking, jam a pole
an
into the ground and
unsus-
drive
yeah.
out 20 meters away, jam another pole in the ground, and then you have like a little
and then
localized network. Yeah.
there won't be a lot of drag to push it over.
Yeah.
If you can get a good seat in the ground.
Any other comments so far? I think Janie might have one.
This is just an add-on to that, but I like the weeble wobbles thing because you could just drop them, just dook, and then just, you know what I mean? You've got a mast that sits there and keeps it upright.
Right.
It's heavy though.
I think what's nutty about my idea is not coming out with a mast that would stand up. You could think of something with a heavy weighted base with a little tripod and then a pole coming out of it. It's how do you collect them all together, ship them on a spacecraft, get them on the ground, and then deliver them to different places without disturbing each other. That's just a lot of extra steps. And since we're not talking about sample return, I don't see anybody wanting to give us the money to do it. So, but I could be wrong. If anybody online or here wants to tell me that I'm wrong, I'm good with that. As people are percolating and thinking about these things, the other thing we should I'd like to bring up is we didn't have any breakout groups for operations. But we have a little time here, I still think. We have another like 20, 30 minutes. Oh, 30 minutes. We got plenty of time. So since we didn't have a breakout group, we're now going to do a breakout group. One giant online in-person breakout group. What are the things we need to care about for operations? How do we want to collect these measurements and return them to Earth? I think it's fair to say immediately that if we wanted to do everything we wanted in terms of data collection, it's a lot of data. We're going to have a hard time getting it back. How do we get around that, right? Do we get around that by changing the frequency of the observations to try to optimize for time of day as time of seasons? Do we come up with some clever ideas for compression? Do we use those magic two words that everybody loves using nowadays, machine learning, to solve this problem? Sorry back there. I just want to hear what people think, or something I haven't even mentioned yet. What do people think about our operational needs for, just imagine your favorite set of instruments that you sent to Mars. I think Jack in the room has a comment, and then we'll see if somebody online does.
Actually, it's more of a question that there might be expertise to answer. So one model would be that your instruments are on the ground and they're only sending up to an orbit, something in orbit, and then to Earth. I don't know, is that advantageous in any way, or instead of trying to send the signal all the way back?
Yeah, if you use an orbiter, you can get a lot more bandwidth. So that would be, I would think that would be the preferred way if that's an option. CubeSats, there's a lot of talk about, do the CubeSats need a relay? So I don't know if that's an option. I was also, there's been, I know for our experiments, we're at a pretty low resolution in terms of like climate data, temperature, and all of that. Our problem is is taking a picture every 8 minutes or every 10 minutes and having 8 cameras doing all of that. So I would think that, there's probably some base data that's going to be, pretty small. And I know there was some discussion about triggered events where you do much higher resolution, higher frequencies of data collection. So that might be certainly one option. But yeah, what we found is the high data volume is the images. And we really haven't talked a lot about imaging, but once again, I'm not collecting stuff at 100 hertz either.
Anybody online have any thoughts or comments on this? All right, well, I'm gonna put someone on the spot again. It's gonna be the same old favorite put it on the spot person. Don, you have an instrument that collects a lot of data. What are your thoughts about how to handle this kind of challenge?
Yeah, I guess I was going to already say that we did talk a little bit about this in our breakout group because Clara was there and she has a lot of thoughts about this, spending an inordinate amount of her time driving instruments on MSL and Mars 2020. I think one thing we talked about was, if you have a lot of landers and you're trying to very carefully monitor, turn them on, turn them off, blah, 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 it would become very quickly overwhelming. So I think you need something that's either autonomous or a very simple ConOps plan. Alejandro, to answer your question, yeah, we kind of baked in the beginning on our instrument that you're not going to be able to send everything back. And so you have to do some onboard processing. For us, it's kind of reducing the data on the spacecraft so that it is kind of the bare minimum for each single measurement. But we really hadn't thought too much about how to choose which measurements among those to send back. But I think that's probably something that'll have to come up, especially if we're going to have inexpensive small landers. You're not going to have the kind of downlink budgets that Perseverance does, or even InSight does for that matter. So you're going to have to live on a much smaller data budget, 10 megabits per sol or something like that.
I think we have a comment here in the room.
Yeah, this is Lior Benenko from Stanford. This kind of continues Serena's point in the chat. I would personally be very interested to know what any of you, what's your opinion about heavily processing the data on board? So for example, having a chip with some kind of a trusted neural network that, for example, can do basic analysis of images. So instead of sending an image with location of a sediment grain, instead of sending the image of a sediment grain, it will send the location in the pixel, which is just an integer, compared to an image, which is a matrix of integers. So would you trust any of those neural networks that on Earth we know are working really well? And I can see a comment about data processing being a power consideration. This is very true. I'm not sure how this compares to sending information. However, today we have neural networks running on really small chips that don't require a lot of power.
So Lior, to understand your question, are you saying, is your example like you would take an image of grains on the surface and let the software determine the size distribution and just send back the size distribution and nothing else?
That is correct, yeah.
Yeah. And then, so the question is, what does everybody think of that? Does that make you panic, or you think it's the greatest idea on Earth, or something in between?
I think that sounds good. Occasionally an image could be taken and sent back, but having statistics and likewise having onboard processing for if a wind threshold is exceeded, then having certain sensors turn on that otherwise would be too pricey power-wise to leave on. And then again, perhaps at the end of that session, all we need is statistics from it. Thank you.
So actually, I'm going to hand the mic right back to you, Lior. Point of clarification for what you're bringing up as a possibility. In this neural network, my understanding, very limited understanding, right, is that the model that's being applied is being developed on the spacecraft. So on the Earth, do we know what the model is that they're using in order to generate the statistics? Okay. Right, because you have to know the model to know its limitations.
Yeah, so you train the model on Earth using terrestrial images, say from a wind tunnel. We talked about sediment grains saltating on the surface. And then you know how well it does. You know exactly what's the accuracy on terrestrial sediment grains. And as long as the images you obtain on Mars look anywhere close to what you see on Earth, then you can guess it's more or less the same accuracy without even seeing the images, of course. It would be, of course, increase the confidence, I think, of everyone if the model could send, for example, the images or the detected, like one image, one frame, freeze frame with even bounding boxes around the sediment grains you detected would be, I think, better.
Yeah, so just to add to that, as long as we know what the model is, and it's not an either or. You occasionally send back raw data, validate it, check it, make sure. Then yeah, I think you can get to a point that people are much more comfortable with that. We're doing some of that with an instrument on Clipper. The imaging spectrometer is doing co-adding on board. So it's taking a bunch of images. So this is an imaging spectrometer due to the surface composition of Europa. And so these spectral scans, it's taking like 20 of them and co-adding them on board. And it's only sending down the processed image. It's also removing radiation noise because you have a lot of radiation around Europa. The reason for that is it compresses the data by a factor of 20, right? Every once in a while, we send back a raw image to make sure it's doing it correctly as we expect. But in general, we're trusting that the onboard processing is doing what we want.
Yeah, I think the difference there, Serena, is that co-adding and removing radiation pixels and stuff like that, I feel like are considered more standard techniques with standard processes. The example that Lior has there is, I think traditionally, we send back an image of grains on the surface, and some people actually would go in and manually determine sizes. And that's what you would be suddenly giving up. And is that something that the community feels comfortable with, that we think we can sell, that we still get the same quality of data and scientific results if we take the human out of the loop that's traditionally been there? I feel this is a very similar debate that's going on in the crater accounting community, where there's still people doing classic, I draw circles, there's a crater, and then other people coming in and going, no, I'm just gonna let my machine learning algorithm do it. And so I'm interested in this idea, but I also am interested in hearing other voices to talk about. You can go next, Lior, but I also want to hear more people from online too, if anybody wants to push back on this idea, for example. Go ahead, Lior.
I'll just say that with crater accounting is one of the most difficult tasks that we can do in planetary science, because if you don't count all of the craters on the surface, basically, and you don't know how to constrain the air, then you'll get the wrong surface age, which is what usually people are trying to get. So here, for example, if we get, I'm just throwing out a pretty low number, the models can do it much better than that. Let's say you got 80% accuracy. You can account for that. You can say, okay, my model has 20% accuracy. I don't detect all the sediment grains, but this is like a representative sample of the sediment grain size, for example, which with craters, it's usually more difficult.
Why not a hybrid approach that sends back a lot of statistics over a number of observations, but once in a while, at some logical interval, send back an image so that you can kind of double check, and anybody that wants to perform other analyses would have that option.
Yeah, Lior is nodding. This is Lori Fenton. So yeah, I think Serena said that too. And I think you said that earlier too, Steve, and I agree personally. So what I was going to say to Lior is, you have neural networks background. We have lots of images, repeat images of grains on the surface of Mars, and people have gone through and done the manual counts. I suggest you get funding to go and apply neural networks to those images, and then prove to us, prove to the community, without a doubt, that it could be done to our satisfaction. And then this won't be a problem. Or not.
Is it okay if I shift topic a little bit, but remaining within operations? Okay,
I was just, sorry, Serena, I was just wondering, could I ask a question before we change topics? How easy is it to change the way that the data processing is done on the rover after we've sent it? Is there a way to change the code on a rover after it's there? We can upload instead of download as well. Is that possible?
Yes. Yeah. I mean, they're always uploading new flight software. I think traditionally instruments don't do a lot of processing on board, but even then, you often need to make adjustments to the timing of observations and other stuff. So they're often uploading new tables, new commands. So there is the possibility for two-way communication.
Well, that's great. I guess you can improve a neural network, although those are, with lots of nodes, that's a lot of data, but I mean, the other thing to suggest is that there are plenty of people that have neural networks developed to extract grain size distributions from images in the field on Earth already. They're actually quite good. So just getting grain size distributions, I don't think would be necessarily that hard. Maybe having a network trained to say something about saltation it hasn't been done before. So there are lots of
and we should switch to the next topic or the next variation here, but I do want to emphasize that Lior came up with that as a point example, not the only thing, but the general idea is what new tools can we use to maximize science return? You want to go ahead, Serena?
Yeah, so as we're talking about, compressing data. So one problem with any time you compress data is you lose the capability for serendipitous discoveries, right? Rather than looking at the image of grains, just to stick with that example, you get back a histogram of grain sizes, you've lost all the other information. What techniques might there be for finding the unexpected discovery? So one possibility that I have talked about with kind of machine learning folks is using some sort of onboard processing to find the anomalies. What do people think of that idea? Has anyone used that in terrestrial science?
That sounds like a quiz you get in high school or the IQ test. Which figure looks different?
Yeah, pretty much. So for a very simple, probably overly simple example, we want to find wind gust. Using knowledge about when we think wind gusts might happen, right? We might design an algorithm or a scheduling process, scheduling strategy that focuses on certain times of day. How do you have something that detects when they happen outside of that time period? Especially if you don't know to be looking there.
I would think the solution is to cover your bets by having a couple of different techniques. Maybe for every 20 analyses statistically, you send an image, or maybe most of the time you let the sensors run on automatic for when you think they'll be active, but once in a while you talk the rest of the mission team into letting you run your instrument for a 24-hour cycle or something like that. It's definitely going to be a hit and miss situation, almost regardless of strategy. There are pluses and minuses.
Hey, Steve, this is Tim Titus, USGS. This is an interesting discussion because we've got like 8 cameras looking at a ripple field, and it's collecting an image every 10 minutes for each camera. And then we download it depending on how often we go out. And now I've got megabytes of images, and I don't have the time to look through all of them. And so in some sense, it's now the human bandwidth that's the problem. And so looking for what's different. This is an interesting problem that applies to more than just Mars.
And to bring it back real quick to Serena's example, James King mentioned online, the Fourier transforms are a good example. So James, I think to expand on what you're saying, I think you're suggesting that we could do something where we have, let's go back to the wind gust example. We have an anemometer on all the time, and it's taking data, and we have a buffer, and we're constantly taking a Fourier transform of some set of that data. And if we see suddenly the power is at a high wind, we know there's a gust, we save that chunk of data, send it back. If we don't see a gust, we throw it away, but we're looking at the power spectrum to decide what to keep and not. Is that what you were trying to get at there, James?
I don't know if you can hear me all right.
Yes.
Yeah, you can do it for wind, but you can also do it for imagery, right? It's not purely a scalar type application. You can do it in 2 or 3 dimensions as well to then resolve differences between days or locations or something like that. So you're compressing the data into it's basically a fancy filter for the data.
Right, and then a simple set of criteria to then make decisions of what comes back and what doesn't.
May I add, this is Don. We did almost exactly something like that with pressure data on In-Situ. We didn't have enough bandwidth in the beginning of the mission to send back every pressure measurement. I guess we never did, but originally we were only sending back like 1/10 of a hertz or something, and we were sampling at 20 hertz. Instead, we took a measure of the variance at 1/10 of a hertz, and we sent that back as well as the average pressure over at 1/10 of a hertz. And it was pretty clear looking at the variance that there were these little periods of time when something weird was going on with the pressure sensor, and we still don't really understand what that was atmospherically. But it highlighted little chunks of data to go back and look at. In-Situ was set up so it recorded every data that was taken, and you could go back for about 2 months and recover that and tell it to play it back. So that's what we did in that case. You don't have to do that. Maybe you have it automatically send back high variance data at the higher bandwidth that you can't support downlinking.
Well, that's a good example of what we've actually done. I had no idea. Thank you, Don. Any other thoughts so far? So from our experience with Meta, then the In-Situ, I think it's called Twins, REMS, and then going farther back, do people have any thoughts they want to share on frequency of observations of the type of alien observations we've done so far? What does that mean for what we need to do in the future? So now I'm backing up, and instead of fancy figure it out on the fly stuff, I'm just also wondering there are thoughts on like how we pre-program the systems to take data. Come on, this is your chance. If you've always had your dream of developing and sharing a concept of ops that no one's ever thought of before, here's your chance. That, or you guys are keeping it all secret for your future proposals.
I'll throw something out for ops because this is my favorite thing to think about is environmentally responsive. What environmental triggers can we measure with a very small, very low power can constantly run at a sufficiently high frequency that will tell us when to turn everything else on so we can get all the measurements we want. Generally, I've thought wind sensor, maybe 1 hertz. You're going to miss a lot of gusts, but you'll catch some of them. And pressure sensor, but what else? And obviously that's from my pet topics of aeolian meteorological. So volatiles group, is there anything that you would want to be watching for that will tell you something interesting is happening right now?
I suppose, and I'm just thinking off the cuff here, if you had a 2-band imager looking at the ground, one that was, say, red, the other one was infrared, near infrared, and then, doing sort of a band ratio. And if the infrared starts becoming significantly more absorbent, passes a threshold, you now know, oh, I've got liquid water or water film or some volatile on the surface, and oh, I need to start doing something else. So that would be, and I'm at the moment I'm more familiar with water, making it darker in the near infrared. Pick your favorite 2 bands and volatile, and but that might be an option. So it'd be and maybe you don't even need an imager. Maybe it could be a radiometer with 2 bands or 3 bands.
All right, so that last set of questions didn't inspire too much, but oh, there's a comment online. I missed it. Sorry.
I would jump in with another point if we're about to leave this discussion.
1 second, Steve. I'm going to go ahead and read what Ed Rivetta wrote. And Derek, I'm going to go all the way back to Derek. Derek said, impact sensor can act as a turn on or off to capture alien flux ripple dynamics. So those of you interested in saltation and other stuff, to use the act of saltation as your trigger. And then Ed mentioned limitations for liquids, at least, is that on Mars, for example, we're talking about small amounts of potential liquid formation, which would be more likely a few centimeters in the regolith. So I think, Ed, are you saying that it's hard to use those to trigger on that? I'm not quite sure what you're trying to get at there.
the example that was given about taking the ratios, that might be limited. You might need a certain amount of liquid in order to actually have that technique work. And so it's something we need to keep in mind. If the goal is to identify liquid formation, we're talking about very tiny bits. So we need instrumentation that's sensitive to very small changes and likely within a few centimeters in the regolith, not super likely on the surface.
Oh, I agree completely. That's why I added in the bit about pick your favorite volatile, and you might have to adjust the bandwidth to look for whatever it is you want to trigger. Because yes, on Mars, having liquid at the surface would be difficult, if not, well, extremely difficult.
So Steve, what was your comment?
Just that I think we're going to have the engineers guide us on the power demands of lander processing, in situ processing versus dumping raw data or some version of it back to Earth. And based on what they say, we would then start planning the details of any given specific instrument. And whichever one makes better sense, I guess, is the way to go.
So the thing I wanted to ask in our final moments for this session, this particular session, is I feel like, at least from my perspective, most of this conversation has been Mars oriented. I wanted to ask both people in the room and online if there's any thoughts of operational constraints or requirements that are more unique to other bodies. So does the concept of operations change if you're trying to do these studies on Titan, on the surface of Venus, or wherever else you want to go look for alien features?
Oh, Janie's not here. I was going to have Janie second me. This is Brian in the room. I mean, Titan has slower winds typically, maybe slow enough that it's not usually saltating anyway. But then when it is active, I think it's mostly during storms when there's a seasonal flip from one hemisphere to the other. So yeah, I would guess, yeah, it's going to probably, a lot of these processes are probably going to scale with wind speed, right? The sampling rates and all those kinds of things. So maybe that's one of the main factors, is thinking about the wind speeds.
Are we about at time? Another 5 minutes. Okay.
I have a comment.
Oh, please, Andrew, go ahead.
So I don't know how the power constraints work for running. Yeah, I guess if you're running an instrument, it's taking power. So some people have suggested that maybe you take like a impact plate or a soltophone and turn the camera on. Derek mentioned that. One thing that could be used as well is just, if the camera is running, you can start analyzing the data or turning on other instruments based off of the correlation between subsequent images, or even, it doesn't have to be an image, just a time series of some signal, some variable. If one way would be to turn things on once the quantity that you're measuring has increased past a threshold. But the other thing you can do is you can, save however many iterations of data from that instrument, and then look at how different how quickly it's changing by looking at the correlation between it and a lagged version of it. And that might be another way in which to, decide some threshold after which you turn on other instruments.
So it sounds like there's some interest in the ideas of triggering, and the question is, what is the mechanism used for triggering that would be robust enough to be trusted? And mostly what I take from all these conversations, including the one going on online between Ed and some others, is there's a lot of technology development potential here. It'd be nice to get more funding from NASA to pursue. All right, so
Hey,
we're
this
coming.
is Don. I have a question maybe that would help just a tiny bit more conversation here. Do
Please,
folks that do terrestrial field work ever try to use a really tiny straw to drink their data through? Because that's basically what we're doing at Mars, or even worse at Titan. And if so, have you guys ever tried to solve that problem? Like maybe a satellite link that you're dealing with or something?
Yeah. When we use the meteorological towers, we're, collecting data at lots of different, high hertz, but we save all the data on board. Just the, at 10-minute intervals, it's all just averages of Reynolds decompositions of variables. And then that stuff is the stuff that's sent over a satellite or cellular network or stored on the SD card on a data logger or something like that. So I think, the way we combat it terrestrially typically is just, it's just doing all of the reduction on board, and saving, maybe losing some machine precision, but nothing super fancy in my experience.
Cool, thanks.
I'd just add that as Joel Sankey at the USGS, we do this with an autonomous LiDAR unit we have in Grand Canyon, where we have it deployed out remotely in the field, place we don't visit all the time, and we can access it remotely. And we worked with basically having that LiDAR scanner turn on when wind speed thresholds were exceeded, and that has worked. And in those data, we actually access as well as just sort of simple weather station data via cellular and also satellite modem connections.
Joel, this is Serena. For the example that you brought up, you said that this technique you found works. Since you're on Earth, where you can measure more things, like, do you have some independent assessment to understand what, if anything, you might be dropping?
Well, it's this kind of straightforward thing of you can't possibly keep, I guess, the volume of data that would be collected if we said, okay, we want this LiDAR scanner to turn on every hour, or for that matter, once a day or once a minute. And so it's instead taking an approach of either you schedule it at a long enough interval that there's time for the data to be collected and the volume of data to be stored and transferred. Or do you instead try to get that triggered with something like a wind speed threshold being exceeded? But it opens up that whole can of worms that everyone's been discussing of you are then just, directing your data collection to only basically these extreme wind speed events, because that's what we were curious about looking at.
Any other thoughts or comments? Okay, it looks like Tim has something here in the room.
Hey, Joel. So this is something we did at Grand Falls Dunefield for a while. We would transmit through cell phone some of our smaller data sets just to get an idea of what was going on, and then use that to trigger when we came out and do maintenance on the equipment, empty the saltation sediments catchers, and pull the SD chips. Do you also have SD chips so that you could actually compare, what was lost by having things transmitted remotely versus what's stored on deck? Since you do have the ability to draw to physically access the area at least once in a while.
Yeah, initially we were controlling it with a data logger, like a Campbell Scientific data logger that I know you're familiar with. And then our engineer replaced that with a computer. And that computer then had a really large data storage volume, and also gave us then the capacity to, upload and download directly from that computer if we remote into it via, and we've used both. In some cases, we used a cellular connection, and others had to use a satellite connection. So yeah, we were able to store extra data basically, or back up our data.
All right, great. So I think we've come at the top of our hour. This has been a good discussion. I'll try to get all this stuff summarized for tomorrow for our plenary discussions. But now I think we're at a 10-minute break. So let's go ahead and take a 10-minute break online and off. We'll be back here at 2:57. Is that okay, Serena? 2:57 Mountain Time, whatever that is, works out to be your time. Thanks, everyone.